Hello and namaste everyone. I am Ranjan Dhakal, your science teacher. Today we are going to study about equation of motions. In previous classes, we studied about acceleration and retardation, distance and displacement along their units and numerical relationship between those quantities. Today, while moving to equations of motions, now we have to first know there are three equations of motion. The first one can be written as V equals to U plus AT, and the second one it can be written as S equals to UT plus half AT square. We can also write UT plus AT square divided by 2. And the third one can be written as V square minus U square equals to 2AS. Here these three relations, they are equations of motions, and the alphabets used here, the symbols used here, they are generally the V as final velocity, U as initial velocity, T as time taken, and S as distance traveled. And all of them are taken in a SI unit. That means the meter per second, the units will be meter per second, second and meter. Now let's move to the proof of all these three equations of motions. Now the first equations of motion is V equals to U plus AT. Now for proof, now what? We have a moving body. A body is moving with an initial velocity of U, and after t second of time taken, its velocity becomes V meter per second. That means according to the formula, according to the definitions of acceleration, we know acceleration is equals to rate of change of velocity. That means we can write acceleration denoted by small a, change of velocity, final velocity minus initial velocity. At the start, the initial velocity is u. After some time, it becomes v. That means the change in velocity will be v minus u. Rate divided by time taken. Now, if we cross multiply this, AT will be equals to v minus u. Or now let's arrange this. We get v equals to u plus AT, which is the first equations of motion. Now the first equations of motions is derived from the numerical definitions of acceleration. I hope this is clear. Now moving on to second equation of motion. Let's move. Second equations of motion, S equals to UT plus half AT square. Now, while proving this again, let's suppose an object, a body, is moving with an initial velocity u. After some time, t time, its velocity becomes v meter per second. And while changing this velocity from u to v, it travels a distance of s meter. That means here there is the cases of two velocities. Before the velocity was u, and after some time the velocity becomes v. That means we know average velocity will be equals to v plus u divided by 2. Now average means mean. There are two velocities. Their mean will be their sum plus how many velocity? 2. That's why divided by 2. Now average velocity equals to v plus u divided by 2. And numerically, or according to the definitions of distance, we know distance will be equals to average velocity multiply time taken. That means from here we can get average velocity, distance traveled s equals to average velocity v plus u divided by 2 into t. Now in first equations of motion, what we have derived is v will be equals to u plus at. This is the first equations of motion. That means instead of b, we can substitute u plus at. Now u plus u becomes twice u, and if we multiply by t, we get s equals to 2 ut plus at square divided by 2. Now let's open this into a V-shape form. V-shape form means opposite of LCM. That is s will be equals to 2 ut divided by 2 plus at square divided by 2, or s equals to 2 and 2, they cancel each other, ut plus this is half at square, which is second equations of motion. Now from two velocities, initial and final, the average velocity becomes b plus u divided by 2. We know the mean of a and b is a plus b divided by 2. Distance is equals to average velocity into time taken. Let's substitute the value of average velocity, and from first equations of motion, let's substitute the value of b. U plus u becomes 2u times t, 2u2, at times t at square, and let's break it, open it into V shape. That means opposite of LCM. 2 and 2 they cancel each other, and here we will get the second equations of motion. Now we move to third equations of motion. V square minus u square equals to 2as. Now again, if a body is moving with the initial velocity u meter per second, after time taken t, it reaches to its final velocity v meter per second, and during this traveling, during this change of velocity, it travels a distance of s meter. That means previously its proof we have brought average velocity equals to v plus u divided by 2. Also, according to the definition of acceleration, a equals to v minus u divided by t. From here, what we get is t will be equals to v minus u divided by a. Why are we getting this? Is because in this relation, third relation, v square minus u square equals to 2as, there is no time taken, no t. That's why we have to substitute the value of t, and for that we are taking the value of t from the definition of accelerations. Okay, we know. Now again, the distance traveled will be equals to average velocity into time taken. That is s equals to v plus u divided by 2 into t. Now let's substitute the value of t with v minus u by a, or s equals to v plus u by 2 v minus u by a. Now numerator multiplies, denominator multiplies. That is s equals to, now the numerator is in the form of a plus b multiplication a minus b. That results to a square minus b square. That is v square minus u square in this case. 2 multiply a gives 2s. Now let's cross multiply. What we get is s into 2a. 2as equals to v square minus u square, or v square minus u square equals to 2as. This is third equations of motion. Today we derived 3 equations of motions where the symbols have a usual meaning of v as a final velocity, u as the initial velocity, t as the time taken, and s as the distance traveled. Their units be in SI unit, that means velocities in meter per second, time taken in second, and s in meter. This derivation, I hope you have understood all these derivations, and in next class we will continue with the numerical problems that are solved with the help of these 3 equations of motion. Till then, stay safe, have a good time ahead. Thank you.